What is the context? What is the context in terms of data flowing down from the satellites? In the last year, the European Commission Copernicus Sentinels program has launched several pairs of satellites producing a large amount of data. So we get like 150 terabytes of satellite data distributed per day. That means that it is actually people accessing those data assets coming from these satellites. And these satellites have different payloads. That means that they have these different sensors on board. Some will look at the atmosphere. Some will look at the reflectance, the amount of energy coming out of reflected by the sun on their surface. And some will have active sensors such as radar, useful to monitor ice shelves or displacement when we have earthquakes or things like that. But the issue here is the volume of the files that we have to process, and also the amount of files that we have to process to extract data. So I think that around today, the smallest unit of a file coming from Sentinel-2 is 500 megabytes. And one single acquisition from Sentinel-1 can range up to 8 gigabytes. And so often to conduct those analyses, you have to combine a lot of these acquisitions also from different sensors and create applications that will be able to extract information out of this data. So the movement in this context has been to push the application towards the data and not the other way around. So in the early 2000s, when I started working in this domain, the policy was still to ship DVDs or tapes to the research centers or the companies so that they would ingest locally the data, process it locally, and extract value. Well, this model could not grow forever. And so there's been a moving. First, we moved to the grid computing, and now, and in the last 10 years, to cloud computing. So by combining the assets of a processing environments plus the data assets all in the cloud, the goal was then to take the developers' applications, the community application towards that environment. And this is the key element of this talk today. So what is the Open Geospatial Consortium? The OGC is an international consortium of more than 530 business, government agencies, research organizations, and universities. And those are driven to make geospatial information and services fair, findable, accessible, interoperable, and reusable. So in the end, us as OGC members, we create free and geospatial standards that are used and implemented by the community so that we create interoperable services that make data findable and accessible. Okay, so the OGC also actively analyzes emerging tech trends and runs an agile collaborative research and development lab that builds and tests innovative solutions to member use cases. So in the 2020, we got two initiatives, the EU applications pilot that analyzed furthermore the common workflow language, and what we call the testbed 16 that combined Jupyter notebooks as an execution element combined with CWL so that we could create applications based on those technologies. So what do these applications, how they do their business? Well, they use to monitor and respond to natural disasters, fires, earthquakes, volcano eruptions, landslides, manage natural resources such as energy, fresh water, sea water level, ice melting, and things like that. Agriculture as well, tracking land use change and biodiversity trends. So we have a lot of thematic domains that rely on combinations of similar assets coming from the Earth observation satellites. Of course, these applications have the role to take raw data or data processed to a certain level and take them to a higher level so that in the end we can extract information in the form of time series, trends, analysis, change detection, and this is the information that those Earth observation applications have to derive of this huge amount of data. So we have been discussing in the last 5 years and in previous OGC test beds the concept of an application package. So this application package is an application, a package somehow, plus its descriptor. And the role of this application package was to take it to a platform, deploy it on that platform based on the cloud, and execute it on the platform. So this application package has to contain the application developed by the developer, the environment, so the computing environment where it has to run, the dependencies, how to invoke that. So the pretty obvious choice here was to use containers such as Docker and to provide, let's say, a package manifest. And in the early days, this application package was pretty much connected with the geospatial world, relying on what we called the web processing service interface. So it had a lot about the web processing interface and little information about how to invoke the application package. And this is why there was an opportunity for the CWL a couple of years ago in the testbed 14. And then at the time, it was simply used to describe how to invoke the command line within the Docker container. And that was enough at the time, except that we still had a big layer of what we call the WPS interface, so how to expose that on the processing environment. So it was a bit decoupled from the application package itself, but more focused on the platform it would run. So this application package, once built and together with its manifest, it can be deployed and executed within an exploitation platform in a service compliant with what we call the OGC API process, which is an open API that allows an application package to be deployed, executed, and to retrieve the execution results coming of that. So this is under active development in the OGC test beds and in a ISA conducted project by Cristiano Lopez, and we, Terra2, and together with Geospatial and other contractors, we worked on that. So our software and assets are on this GitHub repo, okay? So we got invited to this talk because of the OGC Earth Observation Applications pilot. And there, in that context, several companies and research centers went a bit further into using CWL as the manifest to the application package. That means that we found that CWL could be enough or powerful enough, to be honest, to describe what is the application package, how it is executed, but all that decoupled from the processing environment. So that means that an application package could eventually run on your computer or on the processing environment exposed by an exploitation platform. So how does this application package creation process happens? Well, the developers simply create their containers with their runtime environment, their dependencies using Python, Java, C++, whatever they want. And those application developers describe the application package using the common workflow language. The data flows also follow a specification called stack, so that we have an input data manifest and an output data manifest as the interfaces in and out of this application package. And this guarantees the portability between the platforms. So stack plus the common workflow language brings that power to the application package. Then the application package is deployed on a cloud provider, and it becomes a web processing service compliant with the OGC API process, and at that stage it can be exploited. If we look at what it happens in the real life, so you have clients like portals or even APIs, and people usually select a processing service, and the client will invoke the OGC API process. And this is the top tier of 3 elements that we have. The platform then will manage this OGC API process request. It could be a deploy, an execution request, a GET request, and will use the common workflow language that it has stored associated to this application package. And knowing the containers that it references to, it will be able to exploit, to trigger the processing in an environment driven by Kubernetes and using a common workflow runner. And in our case, we use Calrissian quite intensively. And so that means the benefits of the scalability of Kubernetes alongside with Calrissian, a common workflow language, provides you with a powerful scenario and resources to process the large amounts of data that we were mentioning earlier. So if we dive into an application package, so this is your domain, you will recognize that, but we have established that an application package is a CWL document that includes a workflow class as the entry point. So this is a key element. And we had some participants in the OGCA initiatives that would advocate that the interface to the command line tool class was enough. But from our point of view, if we always stick to a workflow class, even a workflow that has a single processing step, which refers to a single command line tool class, it's okay. It's still a workflow, and we stick to that starting point for documenting an application package as a CWL document. So all the inputs are well documented. We need for mapping a processing service with the workflow described in the application package. We need it to be identified, to have a label and a doc, and this is what you have covered in your specification. Then the document includes one or more command line tool classes orchestrated by the steps defined in the workflow class. Then this application package, this CWL document, is posted to an OGC API process endpoint. And this typically is a web server that will receive this the CWL payload. And according to a set of rules that we have established between the CWL world and here, again, with the OGC API process specification, we analyze the CWL file and we create a web processing service. And that at this stage, the rules that we used and created for the mapping between CWL and the OGC API process will provide you with a web processing interface. That is, the server that you contacted earlier to deploy your application package will expose, among its capabilities, your workflow. In this case, for instance, you would discover it as vegetation index, and you would know that you would have to provide an area of interest expressed in the well-known text. This is a geometry, a bounding box or something like that. And then input reference, this is what we call the EO data that has to be processed to extract a vegetation index. A vegetation index is the normalized difference between two reflectances at different wavelengths, and that provides information about the vegetation status. So you see that this endpoint will know how to manage CWL on the south interface to interact with Calrissian and Kubernetes, and on the top, this application package is exposed via the OGC API process endpoint. So what happens when the processing service is executed? Well, the same endpoint as before gets an execute request, and you see this is part of the execute request payload. So you see there is the area of interest with the polygon defined here with coordinates, and then we have a reference to Sentinel-2 acquisition, and we pass data by reference because the platform will know how to stage in and pass the staging element described as a stack manifest to the CWL that is contained in the application package. So those parameters included in execute request are passed for execution by a CWL runner, and then the application package can be wrapped in a macro CWL. Let's say that the endpoint will add to the application package CWL a CWL to do the stage in and the stage out, the stage in of the EO data reference as an input, and the stage out of the results generated on the processing environment. So the processing environment is stateless. It just processes the data and pushes out the result and deletes anything else. So this wrapping CWL can also do other business tasks, such as providing metrics to a system, allowing to measure how this endpoint is being used to produce what. And then the results are returned as a response to a get results request. So you would get the answer of the results that were staged out. You will get reference to those elements staged out. And the nice thing about this approach is that the reference to the results that were staged out can again be used to another process and then you can combine those services alongside. And don't be surprised if we say that we orchestrate those processing services using CWL at a different level. So we also use CWL to orchestrate executions on those OGC API process endpoints. So CWL plays also a role in the orchestration of the deployed processing services. So the benefits that are quite obvious and by using CWL in this context is that the development process of an application is quite easy. You must understand that early on it was quite hard to implement an application and be sure that it would run on an exploitation platform. But here, since we rely on the same tools, so the application developer builds his command line, his or her command line, it gets tested by using CWL locally, and then when you do the Docker container, you can again test what you have, your container with the application with CWL using the Docker requirement hint, and this will provide a simulation of what will happen on exploitation platform. And in our particular case, we also provide a tool to wrap the application package CWL and to behave with the same business logic as a processing would do in an exploitation platform. So that means that the development process and the testing phase of an application got simpler. So we have more insurance that something that is developed in the development environment will run on exploitation platform. And this has a lot of value because it reduces the time to market of those applications. It reduces the failure rate, so you don't consume processing requests that will fail at some stage because you got things wrong. Another benefit is the orchestration, that we saw that it is quite easy to orchestrate to use CWL to create complex DAGs because of how the classes are with the inputs and the steps and the scatter mechanism and things like that, how easy it is to write DAGs. So of course, in the years, we came from other orchestration aspects like Uzi or Beeple and something like that. But to be honest, CWL comes with a simplicity that kind of reduces everything. In terms of exploitation, one benefit, and I think this is kind of a mutual benefit, is that with this approach, we get a solution to process based on the OGC API process to provide a fit-all web service interface for the CWL. It's true that this approach works in the Earth observation domain, but there is nothing hampering it from working in other domains that do not rely on the Earth observation data. And then you get an interface for posting your CWL and getting it executed on Kubernetes resources. And then one aspect is very important to us is the portability. So we kind of want to avoid the vendor lock-in situation. And so CWL has played a great role here in terms of portability. That means an application package well done can be deployed on different exploitation platforms. So you write and you package your application once and you deploy it everywhere. And this has value for in terms of an application developers to see his or her asset move around. So we at this stage, the conversion between the CWL and WPS and the OGC API process has a number of rules that are documented in our report for the OGC. It is a public report, so everybody implementing the application can rely on this information. It will be further consolidated in the EU EPCA initiative, and we're also producing a best practice document within the OGC to reflect how an application package must be done, and we will implement a conformance classes so that we can check that an application package is somehow compliant to those best practices. So the only thing that we kind of miss in the rules to create an OGC web process is what we call in our domain the max occurs. So we managed to create the unbounded, the optional parameter. So the min occurs equals 0 or the max occurs is unlimited. or the max occurs equal 1 with the CWL language. What we couldn't do is to say we only need 2 elements in an array. So let's say if you're producing a change map detection, you will take two observations and 2 only. At this stage, when we take CWL as an application package, we're not able to limit that in the way the processing service exposed. The server will not kick your execution request back if you provide more elements to the array than we needed. And this is something that we have dig into what the discussions in the forums. And we saw that a few years ago, there was this notion of the max items and min items in the enumeration. That would definitely fit our goals. But we'll see how this evolves. And then a nice to have, of course, and we're not the only community to wish to have this, is workflow conditionals, so that we have our workflow reacting to a condition and then taking a different path in the workflow. Maybe it is already in your plans, or maybe already implemented in version 1.2. To be honest, I'm not so confident about the answer to that. And then the conclusion, so the takeaway message for our community is that a developer packages his or her application, creating a Docker, creating the CWL document with the workflow and command line tool classes, the inputs, the outputs, the steps. And then for a platform developer or an actor in the platform business to deploy an application, it needs to extract the CWL workflow information, create the web processing service parameters definition from the CWL, expose this WPS service, and then the client will use that interface to consume the application with the execution request, and the platform in the background will rely on the CWL stack of tools to distribute the processing on the resources. And that was my last slide. Thank you for your attention, and looking forward to hearing from you.